Hi, Math 3 students. So the other day we learned about the law of sines. And in order to do the law of sines, basically the big requirement is that you need to have an angle and its opposite side in order to use a law of sines. You have to have that in order to be able to set it up. But what happens if you're given, let's say, an angle in two sides, right? That would be like a side angle side case. Or what happens if you're given the three sides? In these scenarios, you're going to use law of cosines. All right. And it's another way to solve for a triangle, and you use it when you have a side angle side, which is this guy, and when you have a side side, which is this guy. All right. And I will admit that this is it looks a little bit more complicated than the law of sines. It's a little bit trickier, but you guys can do it. This is the law of sines. So basically you can decide which one you're going to use based on the information you're given. So we'll go ahead and we'll kind of talk about that as we go along. It really is just the same equation over and over. You're just subbing in different parts. So first, let's take a look at this problem here. It says solve for the triangle round to the nearest tenth. So we've got, let's make a nice triangle here. We've got A, B, and C. They tell us that A is 11. Now remember, little a is always going to be the side across from the angle A. Little c is 14, and they tell us that angle B is 34 degrees. So here we have a side angle side case. All right. So we're going to go ahead and we got to use law of sines. Now, law of cosines. So when trying to figure out which one of these to use, if you're given one angle, you're going to want to use the one that has the angle that you're given. So we were given angle B. So this is going to be the formula we're going to want to use here. So let's go ahead and plug in for it. Oops. And one thing I would recommend doing is just kind of always labeling. Like we have side A, side B, and side C. And then angle A, angle B, and angle C. Now we know angle B is 34. We know side A is 14. And we know side A is 11. And side C is 14. All right. So now let's go ahead and plug into this formula here. So we know that B squared is going to equal A squared, which is 11, plus C squared, which is 14. And then we do minus 2. And one thing I kind of recommend is like put parentheses around this. I think a lot of people get confused that this is kind of a quantity. So it's going to be 2 times A times C, side C, times cosine of B, which in this case is going to be 34. All right. Now, when you're solving for a side, essentially all you need to do is plug this big old thing into a calculator. All right. So we can go ahead and do that. Now, again, make sure that you have your mode set to degree. If it's not set to degree, you're going to get the wrong answer. So we have 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. And we end up with that B squared is going to be equal to 61.656. And let's see, does it say, we said round to the nearest tenth, so we'll round that to 61.7. Oh, sorry. No, we're not done. We got to solve for B. Duh. We found B squared. So to find side B, we got to take the square root. Sorry, I was getting ahead of myself there. So then we just do the square root of this guy, which is going to give us 7.852, which we will round to 7.9. Sorry about that. Now, at this point, you might be thinking, oh, well, we've got a side and its corresponding angle. Why don't we just go right to law of sines? Now, technically, you could do that. However, you might end up with something called the ambiguous case. We haven't quite touched on that yet, but essentially, a safe rule to follow is if you start with law of cosines, only use law of cosines to finish solving. All right, so we started with law of cosines. We got to stick with law of cosines. So now let's go ahead. We have to solve for another angle here. It doesn't matter which one you want to solve for. Let's say we're going to solve for angle A. That means we're going to have to go and use this formula here because it has angle A in it. Oop, that's not what I wanted. So we'll go ahead and we'll put that over here so that we can plug into it. So let's go ahead. We know that we need A squared, which is going to be 11, equals B squared, which is going to be 7.9 squared, plus C squared, which is 14 squared, minus 2 times our B, which is 7.9, times our C, which is 14, times our cosine of A. Now I know this looks very complicated, and it is a little bit trickier because now we're solving for an angle, so we are going to have to use cosine inverse. So bear with me here, we're going to get there. So what I recommend doing is first finding out what this is. Do 7.9 squared plus 14 squared. And you get 258.41. Oh, and actually we can do 11 squared too, which is 121. So we get 121 equals 258.41 minus, and then what you're going to want to do is this is essentially the coefficient on your cosine. All right, so you're just going to plug that in and get that number. So that's 2 times, excuse me, 2 times 7.9 times 14 is going to give us 221.2 times cosine of A. So now what we need to work on is getting cosine of A all by itself. Now again, I'm sure this looks pretty complicated, but I want you to think of it this way. If I gave you like 121 equals 258.41 minus 221.2 times x, right? This would seem like it's a little bit easier to solve, right? You would subtract this guy out and then divide by this guy. That's exactly what we're going to do. All right, we're just trying to isolate that cosine of A. So we're going to subtract 258.41. So we'll do 121 minus 258.41. That's going to give us negative 137.41. And that is going to equal negative 221.2 cosine of A. So then to get that by itself, we're going to divide. And we can just take this guy, steal him, divide by negative 221.2, and we get 0.6212 equals cosine of A. So since we're solving for an angle, all you have to do is take the cosine inverse of that. We can just do that on our calculator here. Second cosine, don't forget to use your cosine inverse. And you get 51.59, so we can round that to 51.6. So now, at this point, we've got two angles, so it's a lot easier to solve for our missing angle. So we could go ahead and do 180 minus 51.6 minus 34. And we get 94.4. So this guy here is going to be 94.4 degrees. And I guess I probably should slap degrees on there because they are angles. And now we've solved for our triangle. Very nice. So now let's go ahead and try the next one. So let's draw our triangle out. We can label it A, B, C. So our side A, which is going to be the side opposite A, is 12. Side opposite B is 20, and the side opposite C is 27. Oh, let's see, that's irritating. Well, I guess that's just going to stay in there. So let's go ahead now. We're going to go and solve this. So in terms of figuring out which formula we use, it actually doesn't matter because we just need to solve for an angle. It doesn't matter if we decide to solve for angle A, solve for angle B or solve for angle C. We can just pick one. Let's just do A because that's first. Really does not matter. All right, so we'll put this here, and let's try solving for angle A. And actually we should, right, do A, B, C, A, B, and C. 12, 20, and 27. All right, so let's go ahead and plug this in. So we get 12 squared equals 20 squared plus 27 squared minus 2 times 20 times 27 times cosine, and we don't know what A is. All right, so let's keep rocking and rolling. We're going to get 144 equals, and then we could plug this into the calculator. We get 20 squared plus 27 squared, and we get 1129 minus, and then remember you're going to plug the numbers in there in front of the cosine, so you do 2 times 20 times 27. That gives us 1080, and we've got our cosine of A. So we can go ahead and do minus 1129. We'll do 144 minus 1129, and we get negative 985 equals, and then we've got negative 1080 cosine of A. Then we just got to divide by 1080, or negative 1080, sorry. So divide this by negative 1080. And we get 0.9120 equals cosine of A. So we're just going to do cosine inverse of that. And we get that angle A is equal to 24.2. All right, so now we can go ahead and solve for the other angle that we're missing. And again, remember, if you start with law of cosines, you should end with law of cosines so that you don't end up with what we call the ambiguous case. All right. So just essentially, we're doing this to be safe. So let's go ahead. We can decide if we want to solve for B or C. I don't know. We haven't solved for C yet. It's literally the same thing, but we'll go ahead and solve for C this time around. So we'll put that there. And let's try solving for angle C. So we know that side C is 27, so we'll say 27 squared equals, we have A squared, which is going to be 12 squared, B squared, which is 20 squared, minus 2 times our A, which is 12, times our B, which is 20, times cosine of C. All right, and that's what we're solving for. All right, so we get 27 squared. We get 729. And then we get 12 squared plus 20 squared. We get 544. Minus, and then we could plug this in. 2 times 12 times 20. 480 cosine of angle C minus 544. Gives us 185, negative 480 cosine of C, and then we're going to divide by 480, or negative 480. I keep forgetting to say negative. So we get 185 divided by negative 480, and we get negative 0.3854 cosine of C. So we'll do cosine inverse of that to get the angle. And that is going to give us that angle C is equal to 112.6. So then to find angle B, we're just going to do 180 minus 24.2 minus 112.6. and we get 43.2.